Hey everyone, so today we're going to be deriving the equation for the volume of a cylinder. So we're going to start off with a simple graph, and we're going to have a point on the x-axis labeled h and a point on the y-axis labeled r. Alright, so in order to find the volume of a cylinder, I want you to visualize it with me, that there's a line here at the point r being spun around that x-axis. It's being spun around so much that it's going to create this cylinder. So spinning forward, spinning backwards. And it's going to create the cylinder hugging around the x-axis. So let's first find the equation of this guy right here. Because y equals r. So let's explain that any point on the x-axis, the y value is going to be r. Alright, so to find the volume of a cylinder, you're going to find the area of all of the circles that make up the cylinder. So pretend like we're going to be taking slices from the cylinder, and we're going to find each of those areas. So we're going to find the sum of all of those areas right there. Alright, so the area of a circle, remember, is pi r squared. To find the sum, well, let's take the integral. So let's set up our integral from 0 to h. And we're just throwing pi r squared right there. Don't forget your dx. Alright, so just bring that pi out. Pi from 0 to h, r squared dx. Now because r squared is a constant, we can bring that guy out also. So we have pi r squared integral from 0 to h, 1 dx. Now 1 dx, that'll become x, so pi r squared x, and remember that's from 0 to h. Alright, let's bring it over here. We're going to plug in the h for x, pi r squared h minus pi r squared 0, which that equals 0, so that makes life easier for us, and we're left with pi r squared h. That's the volume of the cylinder, and there you have it.